This video is discrete random variables, the probability distribution function, and expected values part 2. We're picking up with example 4. It says the number of customers in line at a supermarket express checkout counter is a random variable with the following probability distribution. X goes from 0 to 5, and the probabilities are listed underneath each one. Now, what does the 0 through 5 mean? The 0 through 5 are the number of customers that could be in a line at a supermarket express checkout. There could be 0 customers in line, or 1, or 2, or 3, or 4, or 5. The probability of 0 being in line is 0.10. 1 being in line is 0.25, so on and so forth. Now, if we were to add all of these probabilities together, we get a sum of 1. So we also look at the probability distribution and make sure that all of the probabilities are between 0 and 1, and they are, so we're good to go there. So next, it asks us some questions. Find the probability of a 2. So the probability of a 2 is right there. The probability of 2 is 0.30. All right, next, we want to find the probability of no more than 1. So what does no more than 1 mean? No more than 1 means 0 or 1. Because 2, 3, 4, or 5 are all more than 1. We want no more than 1. So the only numbers that are not more than 1 are 0 and 1. So find the probability of no more than 1 customer in line at the supermarket would be 0 customers or 1 customer. So when we have the keyword or, what do we do with those probabilities? We find the probability of 0 and we find the probability of 1 customer. We're going to add them together. So 0.10 plus 0.25, we get 0.35. Okay? All right, so now find the probability that no one is in line. No one is in line. So no one would be 0 people in line, which we already said was 0.10. It looks like there's another one. Find the probability of at least 3 people in line. So what does at least 3 people mean? It does not mean less than 3. At least means 3 or more. So 3, 4, or 5. So when we say, what's the probability of at least 3, we mean what's the probability of 3 or 4 or 5. So that means we're going to find the probability of 3 and find the probability of 4 and find the probability of 5, and we're going to add those together. So we're adding 0.20 plus 0.10 plus 0.05, and we get 0.35. All right, next we move on to something called expected value. An investor is considering a $10,000 investment in a startup company. She estimates that she has the probability of 0.25 of a $20,000 loss, a probability of 0.20 of a $10,000 profit, a probability of 0.15 of a $50,000 profit, and a probability of 0.40 of breaking even. That means a property of 0. Would you advise her to make an investment? So in order to answer this question, we need to find what is called the expected value of the random variable. So expected value, or the mean, when they say expected value, it's the same thing as saying what is the mean. It's the long-term average result if the experiment is repeated many, many times So to find the expected value by hand, we have this equation. First, note the notation, mu with a subscript x. So the mean of the random variable is equal to E of x, which E of x represents the expected value. Notice we use the capital X here for random variable, and that equals sigma. Sigma means sum, the sum of all the x's, all the values of the random variables, times their corresponding probabilities. So what you would do is you would find x times p of x for each random variable, and then add your answers together, and that would be your mean of the random variable, or the expected value. So again, the notation for the mean of a random variable is mu subscript x. E of x is the notation for expected value. These two are equal. All right, now going back, let me just show you how we would come up with this this probability distribution. All right, so first, what are all the possible outcomes? Well, let's just read the sentence. An investor is considering a $10,000 investment in a startup company. So then she's going to estimate the outcomes. She estimates the probability of a $20,000 loss to be 25.25 or 25%. She estimates the probability of 0.20 for a $10,000 profit and 0.15 for a $50,000 profit. Let me erase that. Try that one again. And a 0.40 for breaking even. So breaking even means you don't make any money, you don't lose any money, so it's 0. And so underneath we're going to put the corresponding probabilities that they found for us. So the probability of a $20,000 loss. Now for loss, notice I put a negative. If you're losing, that'd be negative. So that's 0.25. A $10,000 profit is 0.20. And a 0.15 for a $50,000 profit, and breaking even is 0.40. If you add these together, 0.25 plus 20, 0.20 is 0.45, plus 0.15 would be 0.60, plus 0.40 would be 1. So let's look at this example for expected value. Find the mean of the random variable with the following probability distribution. So what we are going to do is you're going to multiply each of the random variables times their corresponding p of x. You can just extend the table. You need x times p of x. So we're going to multiply x times p of x for each one of the random variables, and you can see I've already done this for us. 0 times 0.03125 is 0, 1 times 0.15625 is 0.15625, so on and so forth. When you're finished multiplying all of those, you're going to add all the x times p of x's together, and I believe when you add them together, you get 2.5. So the expected value of that random variable is 2.5. Now let's go back, because I realized that I have skipped a couple slides. I don't know how I did that. But going back to the expected value problem where we initially talked about the investor, here's the table we created to represent that, the probability distribution function, but it is in a vertical format instead of the horizontal that I had earlier. So let's calculate the expected value. So I'm going to pause the video, or you're going to pause the video, not me. You are going to pause the video and see if you can find the expected value the way we did with example 1 earlier. Okay, hopefully you had a chance to do this. So multiplied 0 times 0.40 is 0, 10,000 times 0.20 is 2,000, 50,000 times 0.15 is 7,500, negative 20,000 times 0.25 is negative 5,000. When I add those together, making sure that you put in a negative here, when I add these together, I get $4,500 for the expected value. So what did we just find? So since the expected value is positive, so look, it was a positive number, that means she can expect to make profit. So basically what we found is if we made this investment, the same investment, over and over and over again, a large number of times, the average result would be a profit of $4,500. Now, it's impossible for her to actually make $4,500, so don't think of this as where she's going to expect to make exactly $4,500. Instead, this means that if a bunch of investors made this investment, the majority of them would make money, and their average profits, if you average them together, would be $4,500. Now, we already did example 1. Now, let's think about the calculator. Now, the calculator can help speed up the process. Instead of multiplying every one of these and then adding them all together, we can have the calculator calculate the expected value for us. Now, since the expected value is a mean, sorry, I'm having trouble with my slides today. Since it's a mean, we pretty much find it the way we find mean with the calculator for normal mean. We're going to enter our data. Our X list is going to go into L1, and our P of X, our probabilities, will go into L2. So that's the big difference. Instead of entering the data into one list, we're going to enter our data into 2, making sure that X goes into L1 and P of X goes into L2. Then we're going to do some familiar steps. We're going to hit Stat. We're going to arrow right and go over to Calc. We're still choosing number 1, var stats. We're still choosing that. But when it says list L1, and normally we leave frequency list blank, here we put frequency list L2, or wherever that the probabilities are in your calculator. So this is the one time we want to fill that in. Now keep in mind that once you fill that in, when you do this again, you'll need to delete it out if you're doing a normal mean. If you have no prompts, which is the case for some of the older 84s and then definitely all of the 83s, you will type in stat calc var stats, and then you'll type in L1 comma L2. Then everybody will hit enter, and your expected value is your mean, which is the X bar. Sigma is standard deviation of the probability distribution. So when you do this, you'll notice that there will be a sigma standard deviation, but there will not be an S standard deviation as you're used to. One of those will be blank. So the sigma would be the standard deviation. So why don't you pause the video and attempt to compute the mean of the random variable for the following table that presents the probability distribution of the number of defects X in a randomly chosen printed circuit board, and then come back and see if you got it right. Okay, so hopefully you had a chance to work that. So just to go through the steps quickly: stat, enter. In L1 I have my X's, in L2 I have my P of X's. I'm going to go to stat, arrow right to calc, choose number 1, var stats, list L1, second 1, frequency list L2, don't forget that second 2, and then go to calculate those with the 83s. Make sure you type in L1 comma L2, and X bar is 0.8. So the mean is 0.8, or the mean of the random variable is 0.8. The expected value is 0.8. So if we repeated this over and over again, you'd expect to have 0.8 defects. And then the standard deviation, if asked, is 0.97979, etc. So we'll pick up with part 3.